to like the floor, we might be able to have it sort of go up over the motors, but
yeah, that's kind of what I was thinking too. So this doesn't leave much more room than the balls if we wanted to like move it laterally along the chassis. If we look at like
we can have it sort of go, because there's really, is there a limit for how tall the top of the shooter hood is going to be, other than just from the design constraints in our climber?
Yes,
it's a 4 foot 4 inches, right?
Oh yeah, that too. But I just mean, like, other than that, are we going to have a mechanism above that might get in the way, or can we?
So I have it up here. This is if we use like a 1/2 inch pipe or something, this is what would be in the way here.
Okay, yeah.
I'm assuming that in the middle of the robot, that's all that we're going to have.
Yeah, and I think, Luke, considering the angle you have of the, I guess, bottom plate, which the balls are being sort of pushed against, I think that fits over the Neos.
I think so. Yeah, like right around here.
Yeah. Okay.
Hey, Luke. Oh, I was just gonna say, put that assembly in your chassis assembly so we can see kind of what the scale is. Can you do that?
Yeah, I can.
I didn't mean to interrupt. I didn't.
Oh no, you're good. You're good. No, you're fine. Also, Luke, could you just pull up the dimensions between the two inner plates that the gearboxes are mounted to?
The distance from like where?
Not Neo to Neo, but from the, I guess, frame to frame, like the inner distance.
This distance?
Yeah.
18.25.
How many inches is it?
18 and a quarter.
18 and a quarter. Yeah, I think we should probably have enough room, because each ball is about 9-10 inches in diameter, right?
Probably.
Yeah, so I think we could. The one problem I see with my design, though, is that then we'd have to, if we're gonna pick the balls up at ground level and not have something come over the bumper, then we'll have to take out like that almost the entire front C channel piece, and that's gonna make sort of the stiffness of our frame degrade, or the durability of our frame, make it more flexible.
We can put some structural above, kind of build some structure around the shooter too. Just
Yeah,
to
no,
make
that's a good point.
I do like the idea of just taking out the C channel though in the front, and just picking the balls right off the ground that way.
Yeah, I would agree with you too. I think that's probably the simplest and most straightforward way, that minimal room for failure.
Yeah, so I think this is going to fit. Probably embarrassing myself here.
No, you're good.
Is that not the right direction either? Yeah.
There is no right direction.
All right.
the reason for putting it in there was just so that we could see how well it fits. So even though it's not perfectly oriented, we can see that it appears to fit pretty well.
Yeah.
Yeah, this is good because it's just kind of giving me an idea of how big the balls are, you know, in relation to the frame. So
Yeah.
you might just need to flip one of your top planes there. Oh yeah.
And this one's right. I think it's just being weird.
My question though, for somebody who knows the rule book a bit better than I do, with some of the nitty-gritty details of the bumper section, if we have that big of a gap in our robot, will we have to have a bumper over that?
We need to have 6 inches from each corner. So if it's, I think, 24 inches from corner to corner, so that gives us a 12-inch gap in the middle, right?
Yeah. So that
That
yeah that
is enough to get a ball in, but I don't think a passive intake like that would cut it. That's
yeah, and then
yeah.
if we did try a funnel, then we'd have to have it expand after that, and that might make projecting a ball of an opposite color kind of difficult.
Yeah, that's true. We do need to think about how we can spit a ball back out.
We could
Where-
just
Shoot it
run.
in a weird direction.
Yeah, we can just we could probably just run on a lower power mode to fire it somewhere
Yeah.
else.
We should. Yeah, we can do that. Just have a button that shoots and a button that just dumps.
Yeah, pretty much.
What's the diameter of the ball? We know for sure.
I think it's
9.5.
9.5.
Yeah. So if we go ahead.
you had it there, Luke.
Yeah, I know. It was upside down though, so now I need to go through and flip all of these. Is that
There you
right?
go.
That's right.
Yeah.
Okay. So if we do have like the 1.5 diameter thing you were talking about, so like just put a sketch here. So the balls are 9.5 diameter. So if we want like 15 inches here, then if we like funnel it back in.
Yeah, I don't know if that'll give us the 6 inches on each side, like Max is saying.
Yeah, that's what I was trying to say. I was muted. So I think like yeah, again like Max says, I think the maximum we can have at the front would be like a 12-inch width.
We should be able to get the 6 inches. Yeah,
Oh,
exactly.
I guess with the bump. Oh, because you're not showing the bumper on there.
Yeah.
Okay,
So
so
we
yeah,
can actually-
bumper.
Oh, okay.
Yeah.
Never mind. Sorry.
How wide is the frame then?
15 plus 12 is 27.
Thought it was 24.
Yeah, I thought. Is it not 2x3?
Not in the long configuration, I don't think.
Oh, what is it?
It's like, I don't know, it's on Andy Mark's website. Let me check. I thought it was like 27 by 32.3.
Okay.
Let me check. Yeah. Yeah, it's 27 by 32.3.
Is
We
that
can
what's the size of the frame or the non-Mechnum frame? The one with just the tank drive. Isn't that one a little bigger?
I don't
So,
think so. I
We
built.
can-
Oh.
Yeah,
Do you want to
go ahead.
go, Luker?
Well, I mean, like, we just used the same frame. We just replaced the tank drive with the Mechnum wheels.
Okay,
Yeah.
okay, so it is the same size.
Yeah, you can put the Mechnum wheels in the same footprint. The one problem though is then you can't necessarily have, unless you were to modify your C channel, you can't have a C channel on the outside.
Okay.
You need to replace it with like a custom just metal frame piece, but that's
Okay.
relatively inconsequential.
Yeah.
Yeah, we should probably just put like a long bumper along this side.
Unless, well,
Well,
no, maybe we do want something on the outside with Mechna wheels.
Well,
I don't know.
can I interject again?
Go ahead.
I think one of the problems I ran into with my Mechnum drive was that according to the preseason rules, which based off the actual rules, you have to the bumpers must be supported by by your frame, so you can't just have you're gonna have to have a frame component there, so the bumpers can attach to that. Otherwise, it's illegal.
Yeah, but we can easily put an aluminum plate over there. Not a problem.
Yeah.
Yeah. Even if we can't get away without it, it's probably still a good idea to have something like in the middle here, sticking out. Anyway, yeah. So one thing that we could do is just have like, because if this much of our robot is going to be open, then we can just have like a bit of a funnel along here. And then we could just have like this wheel here. We make it this like actually go out all the way to the end of the frame perimeter, and then we just have like 6 wheels on it, and then like maybe just these 2 wheels over here. Do you guys think that's reasonable?
I think that's reasonable. One thing I would like to add though is how are we gonna power the indexer? Are we gonna have it like a polycord type belt drive? And what you have modeled there are pulleys, or do you have compliant wheels modeled there? And were we anticipating on having like an external chain drive it?
I don't know what wheels we were going to use. That was one of the things I think I mentioned on Discord that we should talk about today. I was just thinking of having like a timing belt here. Go
Okay, yeah.
somewhere. Yeah.
I'd like to avoid the use of chain if possible. Chain is really heavy.
Yeah.
I think we should try to make it so we can like fully control 2 balls and have them inside the robot and do whatever we want with them, because I think that was a weakness of the last robot, that it couldn't
Yeah.
actually hold and control all the balls properly.
Yeah. So I think that if we just move this up a little more, which I already did, then do you mean like 2 balls within the frame perimeter, or would something like this work? Because this is off the ground right now.
As long as we could actually manipulate it properly, then that'd work. But if that actually works, then it works. But otherwise, maybe inside is better. I don't know.
Yeah. One thing to keep in mind is that this is like a full inch off the ground, so we might actually want to put like a little like divot or something in here to help scoop the balls up if we're just gonna do it with these, like lower these down a bit. Were you gonna say something?
Yeah, I was gonna when one of the things I noticed on the 2020 shooter robot was that it's sort of once you have more than one ball in your indexer, then it's really weird in the fact that you have to control both balls at the same time, and then if they're really far apart in your indexer, or one like we may, when trying to intake one ball, unintentionally feed another ball into the shooting position. Maybe not shoot it because the flywheel's on, but do you kind of understand what I'm saying? Or?
Yeah.
Yeah, like
Yeah, that makes sense.
That makes sense, but I'm wondering, can we just have motors connected to each kind of wheel controlling the ball? Does that
with
work?
that,
That's what I was thinking. That's something I was thinking because I think that would be the simplest way. And if we use like the Neo 550s, which would work just fine. Well, like the little tiny Neos,
Maybe
that
yeah.
might work.
Just independent
although
control would work.
yeah, but that'd be really weird to the driver. Like,
I think it'd be like 2 modes, maybe like an automatic mode. And
well,
Cool.
yeah, but like, would there be 2 triggers for each, like one for each roller? That'd be weird.
Well, I think we could probably automate it to some extent. In
But
so that we have a sensor in there that detects when the ball is in its sort of fully contained, like pre-shoot position, where it's ready to be shot, but it's not yet going to be fed into the shooter, right? And then
yeah,
it no longer moves that until you initiate your shooting sequence. But then the lower indexer and lower intake will still continue to function normally.
so we'd have it like 2 rollers and 2 balls, so each roller controls 1 ball.
Yeah, I was thinking like 2 rollers per ball, but the
Yeah.
same concept, yes.
I like that a
I
lot.
mean,
And that, so like one set of rollers passes passes a ball onto the next set, so that like I guess it's only
exactly.
broadcasting one set at a time.
Yeah, exactly.
I like that a lot. That'd work well, because that kind of gives us different spots in the intake with like just one continuous track. That could be really good. I like that, and it might not be too hard.
It'll cost us a motor slot, though.
That's true, but it wouldn't have to be a Neo 550. It could be.
I'm not
I
so
can't remember
sure
what they're called.
we need to be worried about motors this year. Like we definitely were last year, but that's because we had a bunch of different systems. Whereas this is like what 1, 2, 3, and then 4 for the Indic is 7, and then like 2 for the bar, and then if we want to use an entire motor for each end effector, then that's like 11.
How many did we have last year?
Well,
We had 12 motor controllers hooked up to it last year.
I mean, what's the maximum amount of motor controls that we possibly have? Is there a max limit?
16 is what we currently have, but I'm a little iffy on the last 8 of that. We could get a power distribution panel that can handle up to 20.
Yeah, and I looked at the power distribution panel at the start of the preseason just because I was curious. And it is FRC legal. And it's not too expensive. I think that would be well within our budget this year.
I don't think we need it though, because we're only going to need like 11 motors at most. Maybe 13 if we want 2 for each end effector.
The one thing to consider though, which is that there are people on the team which seem really invested in the idea of a turret. And then also we have to I guess animate our hood as well though, right? Did you count that?
That's true.
We do not count
that-
that, so plus 1.
And
just
if we
to
want-
note, a turret would only take 1 motor.
Well, 1 to rotate it, and then 1 to adjust the hood. And then you also
But-
might need
Separate though.
because
we
of the
want
way
hood
that
anyway.
because the way that from my understanding, the way that turrets work, sometimes you need a third like a third feed motor to aid in feeding stuff into the turret separate from your indexer. Just because of the design of it, it's kind of hard to explain on Zoom, but
Maybe we do want a separate feeder for the shooter, other than the indexer. I mean, I recognize that kind of the idea was to have the indexer just I see, to have the indexer go straight into the shooter, but we did something similar last year and that didn't work out too well.
Fine.
2 rollers independently would do the job.
yeah, exactly.
Okay, if we want a motor for the hood, and if we do want like an inertia wheel on the end of the hood, that's another motor. So, I don't know.
Yeah.
What is the maximum number on just a normal PDP?
I think it's 16, but you might want to double check with Hannah.
Sorry, what was that? My phone cut out a little.
What's the
I-
maximum number of motor controllers just on the PDPs we have?
I would say 16, but I'd prefer to keep it below that if possible,
Yeah.
unless we get one of the ones that's fancier.
It is
The-
definitely 16 on the existing PDP.
Yeah, we can't
Plus, the,
we can't do more than 16, but yeah.
and I think the current board we have as well has slots for like, it's got slots for 16 motors, and 8 of which are the high power slots, which are like 40 amps or something.
Yeah, there's
the other
40 amp
8
slots and then there's 30 amp slots.
And we're
And
probably
there's-
we're gonna. No, continue. Sorry.
There's 8 of each. There's 8 of the 40 amp and then 8 of the 20 to 30 amp.
And I think we're definitely gonna need 8. We're gonna need the high power motors for the flywheel, the drivetrain, and the climber rotation mechanism. So that I think that's 7 of the high power motors right there. Because we're probably gonna need at least 2 to move our robot and rotate the entire thing on the climber mechanism.
Yeah, are you counting to actually lift the robot? I would think those need to be high power too.
Yeah, I was counting. I was counting to lift the robot, but I might be.
Well, we can gear
Might
some
be
of that
compressed.
down too. I mean, we can get some mechanical advantage with some gearing, but that's still up in the air. We still got to design that.
So, yeah, about that. If I'm not mistaken, we can just rotate around this point and we can get up to the middle rung. We don't need to attach like an extender or anything. Am I right about that?
Well, you mean you got to, well, from what I'm looking at, you got to be able to let go of the bar, right? You reach up.
That's true.
My
Have you guys decided that we do in fact want to try to climb from one bar to another? Because if we don't want to do that, you don't have to let go of the bar.
I think we should.
Yeah, I think
I think we should
want
at
to
least
try
try.
climbing. Yeah, I want to at least try.
Yeah.
But I'm already making plans to get the parts made too, so I'm gonna be working overtime to try to get these parts made for it. So if that's the way you guys want to go, if you guys want to just try to get the lower bar, then
I wasn't trying to talk you out of going from bar to bar. I just
Okay.
want you to recognize that it is an option. But every year we always have this same argument. We got people who want the robot to do everything. And,
Yeah.
And maybe this is the year that we can do it. But in previous years, we've found that maybe the best thing is to not have a robot that can do everything, but just pick a few things and do those few things really, really well.
Yeah. Yeah, I can.
What?
I was just gonna say that to have whatever, what the issue that I have, at least with the gripper that I drew up, is how to keep holding the bar on the lap, once power's cut to the motors.
So you could try a
In-
ratcheting mechanism.
Yeah, that's true. I could put a pawl in there and just have a pawl engage on the last thing, and that way it would just hold it in place. Yeah, that's actually a good idea.
Yeah. I think the one thing to know is if it's going to be a ratcheting mechanism, I'm pretty sure it has to be custom made. But I think since the grabber's already custom made, then it's not of consequence.
Yeah. Well, it's just another part that has to be made, and it's doable. It's just we got to have we got to have the mechanical done in or as soon as possible so we can start testing. I mean, that's we got to get to we got to fail fast and fail often, right? I mean, that's the first rule. One of the rules of design, I
I
guess.
was looking at like a pneumatic gripper, and the main issues with that is just instead of like sticking pneumatic pistons way far out, which would be really awkward, you don't get a ton of force at the full extent of their their full extent. So it might be slipping, like it would be quite prone to slipping.
So this was my idea, is that like the bar comes in like this or like this. Hold on. Yes, like this on the end effector, and then it leaves like this. So we could do something like this, and then when like the game's over, then this is kind of just gonna like hang on the bar.
Okay.
Yeah, that's what I was trying to say earlier about like why you don't need to grab and release on the same side.
Well, you've got to or both ends of the gripper have to be able to release the bar, right? Or else you can't swing, or you can't go from bar to bar.
Where is so
So,
I made
so if you do have a smaller component there that can collapse or move out of the way so you can release from the bar, and then most of the gripper part is a hook, then that would work too. I just haven't seen anybody draw anything like that, so I'm still kind of in the dark on. I guess I need to spend some more time trying to conceptualize that, but that's where sketches come in. I mean, even I'm just talking like back of napkin sketches here. I'm not talking anything like we don't have to use SolidWorks or anything. Most design work is on the back of napkins at least.
well, this is my proverbial napkin, because like what I was saying is that this is the entire bar, so this would be in the middle of the robot, and this would be swinging around, and we grab it on this end and we grab it on that end. Yeah, but then the actual sides of the climber, like it always enters on the blue side and exits on the red side.
Right.
And then it's in reverse. It enters on the red side and exits on the blue side. So we could have like a carabiner on this side and then just something that can release it on that side. So we could have like an asymmetrical hook.
Yeah, see, you'd have to draw it because I can't visualize it unless I gotta see it. I gotta see it to believe it.
Luke, I kind of was thinking something along the same lines, and I think it would work. It's definitely something that I think would require testing though to see how well,
Yeah, we could,
how well it would work.
Yeah. So the end effector is definitely something that we should prototype.
Another idea I had, I'm not sure how valid this is, but I thought, well, what if we had the hinge in the middle, sort of just like a dead hinge, and we actually use like a, I guess, well, like a knurled cylinder in the grabber that we just use a pneumatic cylinder to really like push into that, or to use those two systems in conjunction and sort of, I guess, distribute the load that we're lifting. The problem though is then, I think to have the knurled the cylinder that's going to be thrust into the bar is going to have to be like probably like steel. It's going to be really rough as well, and it could very potentially damage the game piece it's interfacing with.
What's the rule on that? That's kind of the question I had.
Yeah, because I don't think it would destroy the bar, but I think it would definitely scratch the paint.
Yeah. Yeah, I don't know. I think those bars at the end of at the end of the competition are going to be pretty beat up. But yeah, I don't know. Does it say anything in the rule book about that?
About damaging the parts, the field. Yes.
Well,
it does.
how much can we damage the hanger bars in the? I mean, how badly can we scratch the paint? I guess it doesn't. I guess if we're, I don't know. I'll have to read the rule book on that.
Okay, so it says R201 says traction devices must not have surface features that could damage the arena. It's like metal, sandpaper, hard plastic studs, cleats, hook loop, fasteners, or similar attachments. Traction devices include all parts of the robots that are designed to transmit any propulsive and or braking forces between the robot and field carpet. So
Yeah, that's why I think it's sort of a gray area, because they don't explicitly say if it's interfacing with, you know, the metal, I'm assuming steel bar, what's the threshold for damage there, which is unacceptable.
Yeah.
And then, do we want to go down this road where we're in a gray area and then
Okay,
sort of?
I found the other thing is G301. Robots and operator consoles are prohibited from the following actions with regards to interaction with arena elements. Item F is damaging. So it does say you're not allowed to damage it in the rulebook specifically.
Well, inevitably, it's going to get damaged to some extent, just through general wear. But what's damaged and what's wear, and then you have to deal with, you know, a referee that might have like a stick up their ass or something that's gonna.
I think intent matters though. Like if you accidentally run into a ball weird and cut a slit in it, then that's probably not going to cost you. But if you have something designed to, like, you know, grab something really hard and yeah, as surface features that could damage something, then that's probably not going to fly.
Well, we should probably prototype the End Effector. That's probably something that we should do. It sounded like we had prototyping plans for the intake and then we decided on something. If I'm following the conversation right, do you guys still think that we should try prototyping external intakes?
External meaning.
Yeah.
I think what we talked about on Friday was like just some super minimal external intake. I think something really minimal is the way to go. I was in favor of a crab leg, but I've changed my mind. I don't think that's the way to go anymore.
I think oh, sorry. Did you have something to add?
No, that was it. Go ahead.
Okay, I think we might want to have a working prototype that's semi-finalized of our indexer and our shooter before we finalize the intake, or depending on how we want to play this, even start trying to mount a prototype of the intake to our robot, because certain intakes are going to work best with certain indexing mechanisms. I think it's going to be easier to swap out intakes than it is going to be to tear the robot apart and pull out an indexing mechanism and replace it, right?
I know
that's true.
Yeah.
I know on a Thursday. Sorry. Okay. I know on Thursday we talked about having like a prototype robot for just trying things, and it wouldn't necessarily have to be a Mechnum chassis, or it could be the old Mechnum chassis, but I think we talked about like a practice robot, and with this week like being online, that might not work just timeline wise, but do we still want to have like a robot to just try things on?
Yes,
And
I think that
do,
would be exceptionally helpful. And
yeah.
I would, when we get back to school, if that's what you guys want me to work on, I can definitely work on getting the old Mechnum drivetrain to some state of functionality.
I would
As long as it drives, it's probably fine if we're just using it for basic testing.
And it could even be an old wide configuration, just tank drive that that it'd still work. Probably.
Well, the current Magnum chassis is exactly what Luke has modeled, just with parts sanded off. So again, we really just need to take the gearboxes off, refurbish them, and put them back on, and make sure everything's plugged into the original electrical slots. And from what I see on from what I've experienced with the chassis is that should be enough to allow us to drive it and prototype. Sorry, that was kind of long-winded.
The weird thing was that our current indexer design is like also doubling as the intake with like 2 independently controlled axes here, with like this along the edge with a bunch of wheels, and we like funnel them in. So like they kind of have to work together.
Hey, Luke, I have an idea. So because we have the 2 independent things, I think we could have a design similar to what you said, where we kind of merge the intake and the indexer into one thing, and that I think we could have if we added a third wheel a little bit closer to the front of the robot, and we made that the edge, right? And then the 2 back wheels, or the back wheel, and then I don't know, another smaller wheel somewhere else, work as the sort of the second indexer, and the first indexer can have a component that swings down from inside the robot frame and sort of locks in place. And then we have a chain on there, or not chain, belt, like some sort of propulsion mechanism to transfer movement. And then at the end, then we have just like the little small mechanism wheels, and I think that would be really straightforward and really easy and really simple to build. And so long as the wheels on the outside of it can spin freely as the bar sort of folds down outside the robot perimeter at the start of the match, then it should work just fine.
Could you draw that up? I'm not entirely sure I understand what you're saying.
Here, yeah, I actually think I have a CAD model from my old robot with something really similar. Give me a minute, I might have to.
I'm gonna have to drop off here, you guys. I think you're doing awesome though, Luke, and it's good to hear everybody, Max and Andy. I love all the comments. So I'm gonna I did get a text from Milo saying he's busy with something, so I don't know where he was, but I'll give him 10 lashings for the team.
All right.
Yeah, he'll have to go back and listen to the recording anyway.
All right. Well, we will see you later.
Okay, thanks, Luke.
Luke, can I share my screen?
Go ahead. Do I have to stop mine?
No, not.
I'm not sure. That's why I was.
No, you can share multiple screens and videos on Discord.
Come on.
Just you have to alternate between which one you want to view.
So this is kind of what I was thinking. So this is the CAD model of what was supposed to be in my FTC robot last year. Come on, load. But you can see sort of something because they've got the similar frame perimeter rule extension. And then the idea is that this part right here.
Andy, I don't know how it is for everybody else.
Yeah, yours. Yeah. Okay, there you go. Oh, that's why. Okay.
Can you see it now, or is it not working?
No, it's good right now.
You can see it. Yeah.
It's just really.
Yeah, it's gonna have a really high latency. I was gonna try to animate it, but you can see that. I guess this part right here, that I'm slowly drawing around with my finger, that sort of folds down at the start of the match, and then you can have that actuated really easily by like just a really simple servo. It just has to need sort of nudge it that much forward so it falls down, and then you have a spring or a just a locking arm that falls in place, and then you have it folded down for the rest of the match. And if it's a spring, then you can do some fun stuff where you have it sort of compliant and it can pick up the wheel and control the ball a little better. But so do you guys, did I clarify the idea? Is that?
I see what you mean. I like that. I think something just really simple would do the job, and just something that falls down would do it.
Yeah, exactly. I think I've got to figure out how to unshare my screen. Yeah.
Just press stop stream on Discord.
Okay, that's good. Yeah.
How would we drive it? Just like the one.
You can just have a if you have the main driving rod of your just a minute. Yeah. If you had the main give me a second. I'm trying to put my thought into words.
So you've seen what we did with the intake last year, right?
Yeah, this just has a very simple pivot, and then it's driven. You just have a shaft that goes through the pivot, and then you just put a belt, one for the upper part of the intake, one for the lower fold down part of the intake, and then when you just spin the middle rod, everything else sort of follows, right?
Yeah.
I'll make a really simple prototype out of Legos and bring it to school on Monday, and you can see how it works.
Alright, so yeah, that snowblower idea I was talking about, kind of works like that. It's actually inside, like, the robot, and it'll actually go forward, I guess, on a, I can't speak now, but it'll go forward and, kind of scoop up the balls and bring it in when it rotates back in. It'll, kind of taper into the funnel into the back of the robot into this indexer.
Yeah, so kind of like a hybrid between what they have with their sort of 4-bar linkage and a crab leg intake and the funnel idea.
Well, you've seen a snowblower, right?
Yes.
Yeah, so you know how it has in the front.
Yes, that's a very good analogy. Yes, that's exactly what I was trying to draw early on my whiteboard.
Yeah, that's what I was trying to think of. Is that it's kind of like a helical shape that will move in, kind of take it in.
Yeah, I don't think
can
we
stay
necessarily
the robot.
I don't think we necessarily need a helical shape.
No,
I think we
just something. Well, it's a little weird, make I know.
I think
so. Yeah.
Hey guys, one goal that I have is that we have more than one prototype. So I like the idea of building a snowblower intake in addition to the other intake, and then we look at the prototypes and see which one works the best.
Yeah.
All right. Do you want to prototype that then, Riker?
Yeah, I'll prototype that.
All right.
I'll see if I can't do it at my home. Now,
I'm gonna mock
Tuesday, Monday, Tuesday.
Okay. Yeah. I'm probably gonna do a bit of CAD work on my internal intake idea that merges the intake and the indexer. I might try and build a prototype out of Legos. I'll see if I can. Does anyone else have any other intake ideas that they want to throw out?
I like the idea of just having, I think, an intake that's mostly just an internal intake with some things on the outside to sort of guide it towards the opening in the bumpers and frame. And just some little wheels on the side that we'd have to be careful to make sure they don't knock it away, but just something that guides it into the middle a little bit would be good. Just to kind of increase our chances of actually intaking a ball.
Do you mean like out over the like 6 inches of the bumpers that we have?
Yeah, something outside of the bumpers, but just yeah, I guess.
Okay. I mean, if you want to prototype it, I mean, you're probably going to be doing programming stuff.
Yeah. I don't know. I'm willing to take a look at it.
All right.
One thing I want you guys to keep in mind is that I have a robotics class this semester that meets B5. And I've got 20 people in that. Well, no, I've got 16 people in that class who are available to work during the B5 period on whatever task you guys put them at. So we have more resources now than we usually do. So if you have ideas for prototyping stuff and you can draw them up and explain them to my robotics class, we'll build them.
Okay. I have a free period B5 this semester.
I
So
have a free period on B5 as well.
As do I.
So let's
okay.
say 5.
So it sounds like we have several people who can be there, and
I have robotics. So.
okay. Okay.
So those of you guys who have a free period B5, you might want to consider talking to the counselor and have you transferred into my robotics class. Because what I'm thinking to do is, if you guys work really hard during the robotics season and you work a lot of hours outside of the normal class time, I would be willing to call that good for the entire semester. And so that during April and May, after the competition's over, I wouldn't require you to come in class. I think you would have earned an A for the entire semester.
Hey, Mr. Hendricks, can I do that? And just, instead of doing the normally assigned work, just work on my hydroponics project?
I would consider it. We'd need to talk more details, but I would consider it.
Okay.
Well, all right. Tangents aside, I think also does anyone want to try prototyping a hooded shooter?
I would like to be involved with that. I think that programming is I think programming is going to have to work pretty closely with shooter people because, well, I mean, yeah, we need
I
to
would
make
probably
sure we
work on
can.
that as well. I was going to work on intake, but Andy has a fairly similar idea, so I might work on shooter.
Yeah.
So I apologize for asking a question that you guys probably already discussed. But when you do the shooting, are you planning to use a limelight or some other type sensor to automate a large part of the aiming?
Yes, that we decided that we really just need a limelight for it because it's going to be really hard for a driver to aim for something in the middle of the field, especially with the views from the driver stations. And so, yes, that's a big goal for programming this year.
Okay, I'm very glad to hear that.
Yeah, I think it'll be great.
Just as a quick question, are we allowed to mount cameras onto the robots, or is that not happening? We're not able to do.
And I really think that we should. It would be a massive help to the drivers if they could see what's happening, like probably like
in real time and go there.
Yeah, I volunteer that we add in FPV, the systems that are like really low latency. That would be a really good help.
Yeah, that is definitely allowed and in fact highly encouraged. The only concern that I have is keep in mind the bandwidth. When you're communicating with the robot, if you got too much communication going on, you exceed your bandwidth.
All right, I don't think it needs to be that high definition. Well,
FPV doesn't use Wi-Fi. It uses a different protocol.
If we do use the limelight for targeting, then it probably wouldn't be great for driver vision anyway because the exposure is so low. But we could just have another camera on the front of the robot.
I just say
the driver view.
I just say the cameras, like I guess not as high as a priority as the rest. So I mean, if we have time at the end, I guess we can mount that. But otherwise, it's just focus on the, I guess, the main priorities.
Get away with two. One for like looking at the climber, because that would probably be something that. Actually, I guess the rungs are close enough to the driver station. We probably don't need that. And then one for like the intake and indexer. But yeah, it's not something very important right now.
Yeah. I think we should try to make it as automated as possible. I don't know. Like, we do want the driver to have more information, but yeah.
Yeah, I
Well,
think
Max, that's up
Luke-
to us. So
Yeah, that's up
Programmers.
to us. And we need to be careful not to take on too much, because if we're gonna do the mechanism and also learn how to automate shooting, then that's a lot already.
exactly. Although I don't think we have to worry about mechanism much because
That's true. There's a
there's
lot of stuff
libraries
out
for
there.
it. Yeah.
Yeah. Okay, yeah. Alright.
So, yeah. So I guess the last thing that I should mention is how we're going to like drive the climbing bar. So, we're gonna have something up here. I just modeled it as like, I think, what did I just do? Like half an inch here. What do you guys think we should? What materials do you guys think we should use for the shack tool?
I think we might. I know it's heavy, but we might end up needing to use steel or something, because, I mean, with just the weight of the robot, which I think we
Yeah.
should always design our safety factor, assuming the robot's going to be the heaviest robot possible, right? And then the safety factor on top of that. And then we also have the leverage that we're going to get from the bar, because we're saying like 2 feet from the bar or something.
Yeah. It's gonna be a lot of force, and if the robot drops and breaks, that's
It's not gonna be
that's
fun.
a sad competition.
So obviously, something we'd have to have a high ratio gearbox. The 1 to 100's probably not gonna be enough. I like to move it. I like for it to be really powerful. Also, sorry for my voice. I don't have one today.
So,
no, sorry. Go ahead.
oh, I was gonna say, Mason, you checked on you already did the physics for it, and doesn't like two Neos with 100 to 1s work?
We
Fine.
want that would be ideal. Yes, if we could put. It's running pretty close to the stall torque at that. I mean, it's 44%, but if we could have even more motors to run it, so like 2 on each side, that could help as well. I don't know.
Plus, something to think about with the gearbox is we got to make sure that we don't exceed the gearbox's rating. If I remember correctly from one of our previous meetings, somebody brought up that the 100 to 1 gearbox, the torque rating on the gearbox itself is, we might end up actually destroying the gearbox.
I think that was part of what I looked into as well. Because I think the graph that I looked at, I'm pretty sure it included the rating of the gearbox itself, as well as the Neo. So I think if I remember right, it was pretty far from. I don't know. I'd have to look at it again, so I won't be much help with what I remember.
When Daniel was there the other day, he was talking about this with you guys when we had the meeting, and he did mention that the gearboxes are the weak link. That you can gear it down, but you got to watch the load on the gearboxes.
Yeah, I remember the 100 to 1 gearbox had a lower torque rating than I think the 64 to 1 gearbox had. But if you're using 2 gearboxes for your shack tool, that's distributing the load a little bit, and so that should be able to help you guys out.
are we gonna direct mount our gearbox to the pivot, like the output shaft, or are we also gonna consider something where we have like we mount them lower down in the chassis and then we have a belt or a chain? Or I know you said, Mr. Hendricks, you wanted to avoid chains, but this might be an instance in which the load capacity, that would be the only option. Where and then we have the pulley ratio add to our overall ratio between the rotation of our bar and the actual motor as well.
Yeah, this would be a place where a chain would in fact be justified. And I agree with you, Andy. If we go with a larger sprocket up at the top, we could change the gear ratio to where I bet you that we can make it the gearbox able to handle the load. But I also agree, if we put the gearbox right up the top, like it sounded like you guys were talking about, yeah, I share the concern that would exceed the load that the gearbox can handle. I love your idea of using a bigger sprocket. That fixes that problem.
Something you might run into with a bigger sprocket up top is your robot height limit.
Yeah, yeah, that's a fair point too. And then if we do end up exceeding that, well, actually, what we could do, and this is extra complexity, so it's probably not great, but so we have a length of chain from the top sprocket to a lower sprocket, which is just 1-to-1, right? And it's relatively small but really strong sprockets. And then lower down on the robot, that's where we actually put our big sprocket that's going to be performing the reduction. But then extra complexity, then instead of having, 2 chains on your robot, then you're going to have 4, and it's going to take a while to put it together. Or if it breaks, it's going to be a pain to like put it back together. So that's a thing to consider if we were looking at that.
So,
Oops, sorry.
so the way that I'm currently understanding this discourse is that we'd have probably something similar to what we used on the climber. I want to say last year, but it wasn't last year. In 2020, we had that big steel bar.
If I remember, yeah, no, I know what you guys were talking about. Yeah, and if I remember correctly, I think
climber.
Yes. Yeah. So we'd have something like that, and then we can put like a sprocket up here, and then all the way down in the base of the frame to keep our robot, nice and low. We'd put like all our motors and our gearboxes and whatever, and then we just have a chain, or maybe one chain on each side that we can use to drive the climber from the base.
I've got a question. What is the reduction of the motor of the gearboxes used to actually drive the chassis? Because if we're going to put it down to the base, because of the way the Mechnum drive is configured, we're going to have like that motor mount for the tank drive completely open and completely free. So we could probably use that as a component of our drive system. And then we could have 4 motors to rotate the thing, and then reduce through that, and then we can have the chain do the rest.
Could you say that again?
That is an idea. I like that.
Okay. So, do you want me to elaborate further, Luke, or?
So it sounded to me like you said to have. You said to have the use these mounts here. Is that what you're saying?
Exactly. And then we use the gearboxes, which are normally designed for the chassis, and those are pretty beefy. So
yeah, so those
versus
the gearboxes we already have in the kit of parts.
Yes.
Okay. Let me check what those gear reductions are.
While you're checking, I think another thing to note with a chain, though, is I'm not sure how important this would be, but if we're going to try to automate the climbing, the backlash of a chain, unless it's tensioned properly, is going to be pretty significant. So
I don't know which ones come in the kit of parts, but the Tough Box Mini, the one that comes in the kit of parts, has a gear range from like 6 to 13. 5.95 to 12.75. So I'm not entirely sure if that's going to be enough.
okay, yeah, that is something to consider. Another thing too is that this is definitely going down a rabbit hole, but what about a custom gearbox? We designed a gearbox that can mount there, right? This would require a lot of effort, but it might work.
I mean, it'd probably be a lot easier to just take the 100 to 1 inline ones that Andy Mark sells
Andy,
and just a custom bracket that fits there.
have you seen the Wall of Shame?
Okay, you do have a point.
Yeah. So we could do that though. Just design a custom bracket that fits to the 100 to 1 onlines here, and then we can put one here and then one on the other side. And then we'd have two different chains that both drive that. The thing with that is that the chains would be coming up like right in the middle of the bar. If we have the bar, I guess we'd have to put the bar like here, which might affect the shooter. Actually, yeah, that might affect the shooter though. So it'd need to be like farther into the robot. Is what I'm saying make sense? Is what I'm saying
No,
true?
I think so. Yeah. Another thing that this is a pretty crazy idea, but what if we take the output shaft of the like 64-101 motor or something of that same family, and then stick it into the input shaft of the tough boxes, and then we can have 4 motors drive the thing, and that'll all be a really high gear reduction. But I'm not sure. Now that I say that out loud, it seems like a bad idea.
Well, that doesn't solve the problem though. Is that whatever we put over here is going to be like conflicting with the arms, right?
Well, maybe. But that depends on how far away from the center of the frame put the arms, because they could be pretty close to being near the outside of the robot, right? And that also might be better, because then we'd have a really wide I don't know, chassis when we're trying to grab the bar. But
Yeah, well, the thing is that these are also pretty close to the end of the robot. So we'd have to push it closer in, which not only reduces our like window, so to speak, it also might interfere with the shooter.
what if we use a so you know how we have that plate right there, right? But that we have the motor, the gearbox mounted to. I'm not talking about the gearboxes right now. I'm just using that as a reference for the plate I'm talking about. And then the distance from there to the absolute outside frame of the robot, right, that's about like 6 inches, right? Or not 6 inches, 4 inches.
This distance? It's 4 1/4.
Yeah. So what we could do is use a hollow piece of box tube or a piece of C channel, and then we can run the chain up through that. I guess the problem though is it might be a pain for maintenance, but I'm not sure if it would be that difficult. And then that can be our structural beam, and then that allows us to have the actuation mechanism for the arm and the structure from the arm sort of consolidated into a really compact package. And then the arm can be inside of that, and it still should just be able to narrowly miss where we're going to have our intake and possibly a turret.
Are you saying to put this on the inside of the plate, the side plate?
Yeah, we could put it inside or outside. It doesn't really matter. The point is that the chain goes through the tube, which allows us to shave off maybe about an inch of extra room of room that we'd normally have for the chain to be external. And then, depending on how wide it is, we could actually just cut a slot in the top, and then we actually have our climber inside. I'll present this better on Monday. It's difficult to
Yeah.
describe without
It's not
like having a whiteboard and being in person.
You could try. Does Discord have like a stream annotate thing?
I don't think it does. Not one that I know of.
Okay. Well, yeah. You can present that on Monday then. Yeah. What materials do you guys think we should use for the bar or the arm, not the bar?
I think for the support, for the support, I think we could use the thing I mentioned. We could also look into like C channel or T slot. The actual material. Again, I might reiterate that we probably want steel. Because this is going to have some really, really high loads on it, especially as the robot's going to be swinging, because we've got the lever, and then we've got the weight of the robot, and then we've got the sort of, I guess, momentum or inertia, or whatever the physics word is, of the robot as it's swinging. So, yeah, probably steel.
Okay.
6061 aluminum will hold up, and you'll eliminate the weight.
Really?
And if you're afraid of
You
that,
think so?
you go. Yeah, if you're afraid of that, you go to 7075 if you're worried about it.
Okay,
and
I
if
mean,
you get a thick enough wall, you're fine.
Okay, yeah, because I don't know much about FRC size structures, so.
Okay, well, I guess this is the point where I wish that we're in the lab, because then we could go and look for stuff in the lab.
And don't limit yourself to stuff in the lab. We can buy whatever you need.
Well, that's true.
Pretty sure it was aluminum.
I think it's aluminum box tube.
Yeah.
I think the claws were like steel or something. Steel covered in a little protective casing.
You're talking
just
about
the
the one
claw.
that back when Dean was around?
Yeah.
The Ben climber.
Or Ben, I mean. Yeah, that was aluminum. And the hooks were
no.
aluminum as well. And they were plastic coated on the ends.
Well, if that works, then I think it should work. I think just beef up a similar device, and I think we should probably be fine.
Yeah. So, yeah, I'll probably throw that into the model and make sure that our geometry works so that we don't need like an extender or anything. Yeah. I can't think of too much else to talk about.
I have one more quick thing. What about our center of weight? Because we're gonna want to have that. Because we want to think about. I think we're probably gonna have that. We want that low in our robot, right? Because we don't. Because I saw the video you guys played up on the smart board at school where one of the robots pushed the other robot over and it like fell over and died. And I think if we're gonna have a really tall non-extending mechanism on our robot with a lot of weight on top, then that definitely will become a possibility. So
Lower is always better.
I mean, I don't know if we have much of a choice. We can put our gearboxes and everything as low as possible and then transmit it to the top of the robot using a sprocket, and then sprocket and chain and then just use aluminum for as much as we can. I don't think a churro's going to handle the torque. Do you guys?
I don't think there's any hope of that.
Yeah.
It'll be fine.
Do we have like a beefed up churro somewhere? Is there somewhere online we can get a beefed up churro?
I think the half-inch hex shaft is steel. I'm pretty sure the half-inch hex shaft is steel because when you put it on a grinder, it makes sparks. So
Yeah. So we should probably just use that then, and then just aluminum for as much as we can. Maybe some tougher stuff for actually gripping the bars, but yeah. I don't know if there's very much we'll be able to do about our center of mass. Anyway, yeah. So, you guys that are going to prototype stuff on Monday, you all know what you're doing. You guys that are going to prototype stuff at your house, you know what you're doing. Does anyone have any other concerns they want to bring up?
I just want to make sure that we all understand what the plan is for Monday. So are we planning to stay there until 8 o'clock Monday evening?
I'd definitely be able to do that.
Yeah, sounds good to me.
Yeah.
I have nothing to do,
maybe
so
that
you
works.
can do. I can do that.
I'm not
Is
entirely
there-
sure about my plan, but yeah.
Okay, I'll talk to the business team and see if we can get a parent to bring us some dinner on Monday. What about the rest of the week?
I mean, we gotta make up for lost time this week. So, sure.
We're in the thick of prototyping and design, which we were supposed to be doing this week. So,
Yeah.
you probably.
I can
So how
come
about-
like every day.
Yeah, well, the original plan was we would work Mondays, Tuesdays, Thursdays, Fridays, and Saturdays. So you want to go to that plan now, effective this coming week?
Yep, sounds good to me.
Again, just a quick question. So I've kind of been all over the place with the ideas I've been coming up with. Is there a very specific area in which you'd like me to really focus on? This is just a general question. Or
Who are you asking?
well, what do you want me to do for the robot, or should I just pick something random? Because I've got ideas about everything, and therefore the time I'm going to have is going to be spread out across multiple teams, and that's not really great. So is there one team which you think just you, Mr. Hendricks, and you think I would, I don't know, do really well on and should concentrate on?
I like having all of your ideas in all of the areas. As far as where you put your time, let's just see. I took a quick survey, and I found a lot of people are interested in working on the climber. A couple people working on the shooter. I didn't find very many people who express an interest on working on the intake mechanism, and so I'm a little concerned that we're light on that area.
I could work on that then.
Yeah, smart idea.
I'll be
additionally-
working on the intake as well, so I'll be there to help.
Just Friday, because there's like clubs or something now. I don't know the exact schedule.
Yeah, the plan for tomorrow morning is we are meeting on a regular Friday schedule. So that means from 9 o'clock until 9:40 will be club time. And yeah, I'm glad you reminded me. I should send out a message with my Zoom link on it. Those of you that are in my classes, you know I have a Zoom room and I use the same link for all of them. We should plan to get together in my Zoom room tomorrow from 9 till 9:40. And we can talk about these very things that Andy just brought up about who's going to work on what.
Yeah, that could work.
Yeah, that sounds good. I think I'm gonna leave. So
Yeah, I have some dinner waiting on the table now.